What's up, good people? Welcome to section 4.3. This is your boy, Mr. B, right here. We're going to solve x squared plus bx plus c equals 0 by factoring. Now that we spent last video and last lesson factoring, we're going to use it. And we're going to use it to solve new and more complicated equations that we've never seen before. Let's talk about what we have seen before. We have seen 3x equals 9, 4x plus 2 equals 10, and even absolute values in here. And the basic overall technique was to undo operations in reverse PEMDAS order, SADMEP. So like you undo in this example, you undo the addition first, and then you undo the multiplication. Or you could undo the grouping symbol, like you could think of absolute value on the same level as parentheses, undo the multiplication first, and then undo the absolute value, and then last undo the subtraction. And when do we do that? We do that when there's only one x term. Like here, there's only one instance of the letter x in all of these equations. You only see one here. It's going to be different for the ones we have here. I want to also say that when you have like something like 4x minus 3 or 5x minus 6, the basic idea is just to move these terms or combine them so you get back to only one. Like one thing you might do here first is subtract 4x from both sides. That could be a good first step. And that basically taking those two terms that are like terms and putting them back into one like term. But we're going to move into some very different equations. And so the idea that you want to undo operations by moving stuff over from where the x is over to the, for example, move the 2 over, move the 4 over here, is actually not going to work at all, because look at this. There's two different instances of the variable u here. There's two different x's here, so you couldn't possibly move both the square over and the 3 over at the same time. It just doesn't work. So we need new and better techniques. Introducing the zero product property. Basically saying that if you have two numbers, I'm thinking of two numbers here, and I'm multiplying them together, and guess what? After I multiply them, I get 0. Well, then you got to know that either one of them has got to equal 0. That's the zero product property. And it basically utilizes something called factored form. If you can get your equations into factored form like this right here, then what you can do is split. Very new technique. It requires that you, like I said, equal 0. You got to have two separate things that are equal to 0, and then if everything over here is equal to 0, then you can split them up. Like here's what it looks like. Let me show you. Okay, so if you have the 3x plus 1 times the x plus 2, and those both equal 0, well, either one of them could equal 0. And so we're going to split them from a very complicated equation into two much simpler equations. All right, now that we've split, we can actually, after you split them into two simpler equations, you can actually go back to undoing operations with SADMEP, like we've always been doing. We undo the addition, we undo the multiplication, and we get our two answers. Sorry, it might look like there's only one, but there you've got x equals negative 2 and x equals negative 1/3. Those are two different answers. That's the only way you can do that is by splitting them up. And the only way you can split is if you have them in factored form, like this, and it's equal to 0. The impulse is going to be to move things over, but you can't. You have to keep them all over. You have to do the exact opposite. You have to keep everything over here on this left-hand side and nothing over on the right-hand side, which is very strange. But let me show you some more examples. Over here, this is in factored form. We've got something, a binomial, as we learned from last video. That's two terms. This binomial times this binomial is equal to 0. Great, that's factored form, which you're allowed to split into two different equations. And then we can solve these two equations by undoing, actually I added n here, and I subtracted 2 here to get the two answers of 1 or negative 2. Notice you can put the 1 back into the original, you get 1 minus 1 is 0. Or you can put the negative 2 back in, you get negative 2 plus 2, which is 0. It doesn't matter what the other term is. If you multiply anything by 0, you're going to get 0, which is kind of like the magic of the zero product property. Here, look at this. This is wild. We've got 1, 2, 3 things, and they're all, when you multiply them together, they could equal 0. Well, that means these three different things can be split up into three different equations. This part could be equal to 0, z minus 1 could equal to 0, z minus 2 could equal 0. And so you can see here we have the answers. All right, so the real trick is to get things into factored form. Like, how do we, this is new. Splitting things up, I know, is kind of new. But we're also going to try and figure out how to go back here. We're going to set these things equal to 0, and we're going to factor. Just like we learned last class, we're now going to actually use it. When do you do it? You do it whenever you have two unlike terms with different exponents. So for example, here you can see 3u squared minus 15. You can't combine them. You have the u squared and the u. Those are not like terms. And moreover, you can't just undo operations with SADMAP because you've got two different occurrences of the letter u. That's got, like, if it were just 3u, just negative 15u equals 0, fine, undo your operations. But here you can't. There's just too many operations to undo, and you don't know which ones. So we need new techniques. So here, what we're going to do is the process is going to look like this. We're going to set things equal to 0 if they're not already. We're going to factor them like we did last class, and then we're going to split them up to solve. This is what it looks like. It's okay. Step 1 is fine. We already set equal to 0, and so then we're going to factor. We take these two terms and put them here in the middle, and then we say, oh, this is just like last class, just like last video. What's the greatest common factor between these two? 3u, because 3u multiplies up to both of these terms. Then what is the leftover? U. What's the leftover here? Negative 5, because 3u times negative 5 is negative 15u. Now that it's like this, we can write it in factored form. This used to be here. Now we've factored it, and because it's in factored form, we can split. And now we can solve. And now we have our two answers. Notice you can put either 0 here in the original, and it works as a solution. Or we could put 3 up here. 3 times 9 is 27 minus, timeout. I'm so glad that I decided to try and check my answers back in the original because I found a mistake. Look, it was right here. U minus 5 gets split into u minus 5. I don't know why I wrote 3. But then when you solve it, u equals 5. Whew. Berg, let's go. Gotta be better than that. All right. Here, you might say, I need to move the 6 over or something like that. But what I'm noticing about this equation is that it have two different terms that are not like terms. You can't subtract 18u from both sides because and expect it to cancel out here because, like, this is a squared and this is a w to the first power. So in the end, what we have to do is we have to recognize that we're in this bottom situation. We have 2 plus unlike terms that have different exponents. And so I'm going to actually set things equal to 0. So yeah, let's subtract 18w, but they're not like terms, so they don't combine. So you have to write them over here, and now that it's equal to 0, we're in a good place to start factoring. Take the two terms and put them in the middle, and think, what is the greatest common factor? What thing will multiply up to both 6w squared and negative 18w? Well, 6w. 6w times what is 6w squared? That's w. What's the leftover over here? Negative 3. Then join them with multiplication. Notice you started with an equal equation and continue setting these things equal to 0. But because it's in factored form, 6w and w minus 3, we can split them up and solve. And now we get our two answers. Let me check. Back in the original, yeah, 6 times 0 squared is equal to 18 times w. And if you put a 3 here, this would be 54, and this would also be 50. Oh yeah, they work. Okay, both sides are 54. Over here, I'm noticing that I can't just, you might have the urge to subtract 6 from both sides because that's what you've been trained to do for these kinds of equations, undo the operations. But if you subtract the 6 from both sides, you'd be like, what do I do next? I don't know. So you have to actually keep things over on the left-hand side, all grouped together, everything set equal to 0 because we need to use this 0. We can't split unless we have everything set equal to 0. We instead factor. And so we've got 6. And then what numbers multiply up to 6? Oh, yeah, 1 and 6. So I'm going to put them, now that I can split this middle term, I'm going to put all 4 terms in the box. And I find a greatest common factor. greatest common factor here, greatest common factor here, greatest common factor here. Join them together with multiplication. Split them apart with the zero product property. Undo the operations. Next, here, I'm noticing that I can't just undo operations because I got an x squared and an x, and how do I undo all of that? I can't. So I'm going to recognizing that I now need to use the zero product property to split. I've got two or more unlike terms with different exponents. So therefore, now I'm going to set equal to 0. What numbers multiply up to 8? There they are. I'm going to split this middle term into two different terms, so I have 4 terms that could fit. And I'll use 6x is the same thing as 2x plus 4x. Greatest common factor, greatest common factor, greatest common factor, one last GCF. Join them together with multiplication, set them equal to 0. Just like they were up here, this x squared plus 6x plus 8 is the same thing as this down here. They're both equal to 0. But because they're equal to 0, I can split them. And I can solve. Your halftime show is brought to you by Mr. Bergman's favorite Thanksgiving dish. It's coming up soon at the time of this recording, pumpkin pie. Why don't you let me know what your favorite Thanksgiving dish is? Mine is pumpkin pie. What's yours? Okay, back to the math. And we're almost done. We've got, here I've got 2 different terms that are not like terms. They've got different exponents, and so this is just going to be too complicated to undo. We can't undo all the different operations. Instead, we've got to set everything equal to 0. So we've got to put everything back onto the other side, as opposed to these kinds of equations where you can just undo and move everything. You move the 4 and the 2 over. In this particular equation, you have to group everything together, put all the terms onto one side, set it all equal to 0. And only in that way we'll be able to split later on. All right, what numbers multiply up to 20? These numbers multiply up to 20. And only the bottom one, the very last one that I found, also happens to add up to -9. We split them up like this because -4, -5, -4x, -5x. That's how we'll split up that middle term. Now that we have 4 terms, we can find GCFs to factor. Here, here, GCF here. Well, it's kind of hard to see what is the GCF because this one's negative and this one's positive. So you could also ask yourself, x times what gives you -4x? It's just got to be -4. And over down here, x times what gives you -5x? That's got to be -5. And now we can join them together with multiplication. And because it's 2 different things multiplied equals 0, you can split them up and solve. Next, I see 2 different unlike terms. I recognize that now I've got to set everything equal to 0. In this land of like more complicated than just undoing operations, we've got to get used to setting things equal to 0. Move it back over to the other side. X squared plus 4x minus 12 is equal to 0. These are the numbers that multiply up to -12. And only this one here, 6 and -2, also happen to add up to +4. So I'm going to split up this 4x into 6x and -2x. Greatest common factor here, greatest common factor here, greatest common factor here. Actually, x times what gives you 6x? That's 6. The leftover over here is -2. Now I join them together with multiplication and separate them using the zero product property and solve. Here we see x squared, we see x, it occurs twice with different variables, different exponents. So I can't just move the 18 over. You might really want to move that 18 over, but you can't because it's you would add 18 to both sides and then you'd be like, oh, what do I do next? I'm stuck. Well, the way is you got to keep everything set equal to 0. You've You got to look at that negative 18 and say, what number is multiplied to negative 18? And here, this one, 3 and negative 6. So I'm going to separate this negative 3x into 3x, as I found here, the positive 3 and negative 6 x's. All right, greatest common factor here. And then what times x gives me x squared? X. What times x gives me negative 6? Negative 6. What times x gives me 3x? 3. And then we see all these down here also work out. Great. Join everything together with multiplication, separate it with the zero product property, and solve. And I want you to tell me what's underneath this red dot. Here, oh, I noticed the greatest common factor. This is something you might want to start thinking about now, is what is the greatest common factor between all these three terms? Oh, I noticed these are all even. So if you wanted to, you could divide all the terms by 2, and that just gives you lower numbers to work with, which are going to be always easier. Like I'd much rather find out over here, I'd much rather find out the numbers that multiply up to 9 than the numbers that multiply up to 18, because there's just way more possibilities. So let's figure out what numbers do multiply up to 9. Here they are. The positive ones aren't going to work. You actually need negative 10, because negative 1 times negative 9 is positive 9, and then negative 1 plus negative 9 is also negative 10. That means I'm going to split up this negative 10 into negative 9n and negative 1n. Greatest common factor. Oop, that should be an n. It should be n squared right here. N times n is n squared. And then negative 9 goes here. N times what gives you negative 1n? It's negative 1. And we get what we need. Join them together with multiplication. Separate them with a zero product property, and solve. Thanks, y'all. You've been great. Bring your questions to class, and I'll see you in class.